All right, guys, so last week we were calibrating this DP cell right here. It's an Anderson-Hauser DP cell. We used it to look at the level in our tank going from 10 to 50 centimeters, and it quickly calibrated to provide us with a 4 to 20 milliamp signal there. So at every 25% increment there, we got a 4 milliamp increase. So we had 4 milliamps at 10 centimeters, then we had 8 milliamps at 20 centimeters, we had 12 milliamps at 30 centimeters, 16 milliamps at 40 centimeters, and 20 milliamps at 50 centimeters. So every 25% increase in the level corresponded with a 4 milliamp increase in the current coming out. That one quickly was, we were able to quickly calibrate that guy compared to the previous labs where we're using the lab wall trainer. In that this DP cell is worth like $1,500 to $2,000, so it should provide us with a gorgeous output once it's calibrated. So now that we've calibrated, we then started in on the same lab and we started to work on a PLC program. So I wanted to do a video to kind of walk you through exactly what we're doing so that you could watch this video, and if there was any confusion on the calibration there, sorry, not the calibration, but the actual PLC program, that I could walk you through prior to going into the lab. Okay, so this lab takes about two labs to get through. It takes about an hour and a half to get through. So this is going to be a long video. The beauty of this is that by the time we're done, we're going to have an HMI display, and you can see that the trainer is above here. The HMI is right here. So this screen right here is going to eventually have these three graphs. So it's going to have one graph for level. Let me see if I can increase the zoom here. We'll just take a look here. So we're going to have one graph that's going to give us the level. The other graph is going to give us the 4 to 20 milliamp output. And the next one is going to give us a percentage that corresponds to this current value. We're going to see that all of the graphs change simultaneously, in that if we were at 75% of the level in the tank, then we're going to be at 40 centimeters. We should get 16 milliamps out, and that should correspond to a 75% here. Okay, we're also going to have values that correspond here. So this here at 50% gives us 30 centimeters, 12 milliamps, and 50%. Okay, down here, these are just labels: centimeters, milliamps DC, and percentage. Okay, over here, we're also going to have two push buttons here. So these are going to increment and decrement the voltage to our pump. Our pump is controlled by a DC drive, and the DC drive takes a 0 to 5 volt signal in. So by incrementing or decrementing on those push buttons, we're going to change the 0 to 5 volt signal to the pump there. We're also going to have a digital display that tells us the voltage from 0 to 5 volts that's going to the pump, and we'll have a percentage output here that corresponds to that 0 to 5 volt signal that we're sending to our drive. Okay, I think that covers everything there. So as you're going through this, you have a paper copy of the lab, right? So you are basically just going through your paper copy and just turning the page, page by page. If you get to a certain point and you're like, what is going on? I don't see that on my screen now. Then flip the page, and basically this lab is set up as you go through. It's like, this is where we're going, and if you flip the page, I will walk you through how to get there. So if there's a little bit of confusion, then just keep going. Ask me questions as you go in lab, or refer back to this video here. The other beauty thing about the lab is that our screens are a decent size, so you can have it how it's set up like this, where you have half of or like a third of the screen set up with a PDF, and then the other 2/3 of the screen is set up with the TIA portal. I'm going to get myself out of the way in 2 seconds so we can go through this together, and I'll get rid of the PLC that's above and my face, and you'll see that you can see both the PDF and the PLC program simultaneously on the screen there. The way that I did that was that I grabbed the PDF, I open it up, and I just snapped it to the side, and then it snaps in and takes up that portion of the screen, and then you can click on your PLC program and it'll take up the other portion of the screen. And then as you change the sizing of it, then you can see more or less of the PDF and more or less of your Siemens TIA portal there. So it's up to you whether you want to go through on the paper lab that you're going through, put the PDF on the side here, or maybe you brought in your laptop or your tablet and you're just scrolling through on the lab there on your tablet, and then having the full screen for the TAA portal. It's up to you how you want to take advantage of this. Okay, so basically what I'm saying on this first page is that I'm throwing you in the deep end here with the PLC programming. You have never touched the PLC. You've never seen this trainer before. We've never walked through how to set up the base PLC program. I'm just throwing you right in, and we're going to do analog inputs. We're going to do NORMx and SCALEx. We're going to do HMIs. We're going to do some math functions in the PLC. So I'm basically taking you from zero to like if this was a PLC course, we're like already in week 10 of a 30-week course here. So we're driving you right into the deep end here, but I'm hoping that I know that the lab will work because I've done this with numerous students, and the lab is, to pat myself on the back, this lab is pretty damn good in that there's very few issues, and it slowly, methodically walks you through how to take on this PLC program and this HMI. And we'll work together within this video to deal with any issues that come up, or anything that I've misquoted within the lab here. Okay, so it's basically saying that I'm throwing you in the deep end. The next thing I'm asking you to do is to open up a base PLC program. So we're not choosing which PLC to work with. We're not choosing which analog card. Everything is already set up for you, so we can open up a base PLC program and already start programming. You're going to open up an existing project. So it says open up an existing project here, which is right here. Okay. And then you're going to scroll through and you're going to find in the intermediate instrumentation folder, the base PLC program. Below it says that I've labeled this as the 533 Siemens base PLC program. As always, I change things. So you can see here that in the intermediate instrumentation folder, if you go to Siemens PLC programs, it's no longer called that. I've called it the S7-1214C base PLC program. So open up that folder and open up this Siemens TIA program, S7-1214C base PLC program 2020, and that will bring up the same program as I've quoted there in the lab. Okay, I've already done that here, so I have that available here. And the next thing I want you to do is I want you to click on right below here the project view. So let me get myself out of the way so we can just have the screen capture. And I'll bring this image up. The beauty of this with the OBS is that I can come in every once in a while and talk to you, camera to face here, and I can also show you the actual trainer here. And so we will physically be pressing stuff on the HMI, and then we'll be seeing a change real time on the screen here. So let's go just to the screen capture here and let's walk through. So it says to go to the project view, so let's do that. So I'm clicking on project view, and you most likely will not have this come up. You'll probably have just the base PLC. So what I'm doing is I need you to go to PLC 1. So that is right here. So I'm clicking on PLC 1 here. Okay, so you can see here that this image right here doesn't have the full menu here. So if I click on the arrow, it's a single click here. If I do a double click, it comes in and comes out. So it's a single click. And what I want you to do is it says go to PLC 1 and then go to device configuration. So that's just below here, right? So PLC 1, device configuration. It's a double click and then it opens up this image right here. Let me minimize these guys here. And let me get this out of the way. Okay. And you will see that in yours probably opened up to 100%. So it was quite small here. So you can go down on the bottom here. So you can see my mouse right here. And you can click here and you're choosing either 200%. And it's frustrating because it moves it over to the side here. So 200%. I find that actually 400% is pretty good. So I can actually see the PLC. Okay. And if it moved it over to the side here, then just scroll over and you'll see the PLC. And you can see the digital inputs on the side here and the digital outputs here. They correspond to the digital inputs right here and the digital outputs. We're not going to be making use of those in this lab. We're going to be making use of the analog inputs on the side here. If I scroll over just a touch, then you will see that I have the PLC, and then I also have the analog card right here. If we look at our actual trainer here, then we have the 24-volt power supply here. This is the PLC that corresponds to this guy, so they're basically identical now on your device configuration and the actual trainer. And then right here, you might just be able to make out that there's an analog card. That analog card is this bad boy right here. Okay, so PLC, analog card, the only thing that's not being shown in the device configuration is this 24-volt power supply that powers everything up. Okay, let's keep going here. So what I want you to do first is, let me just make this a little bit smaller here. I want you to click on the actual PLC. So don't click on, so there's a number of things that will screw us up here. So don't click out here because that's not the PLC. Don't click on this box right here because that's actually another analog card. Just click on the general PLC right here. So maybe go between Siemens and Siemens S7 1200. Click on there, and then we're going to go down to properties here. Okay, this may not have opened up. It may be below here. So if I need this to come up, you can come to the bottom here, and I don't know if you can just make out that my mouse changes there. So once I see this image change from the arrow to this, I'm going to, let's see, I'm left clicking here and I'm dragging this up so I can actually see the properties of the PLC. It may have opened up to the general here. I want you to go to the Profinet General Ethernet addresses. So we're going to Profinet General Ethernet addresses. It's a single click there and it opens up this image right here. Okay, all I'm doing is I'm just asking you to confirm that the IP address is 192.168.0.10. So we can see here that is confirmed, 192.168.0.10. You'll notice that the other PLCs in the lab are networked. So we have the Schneider PLCs that are networked in Ted's class. So they all have different IP addresses. So every single station has a specific IP address that is distinct for that station. With us, with our Siemens trainers, every single box and every single PLC has the same IP address, 192.168.0.10. The beauty of that is that you're not connected to the network, because what we did was we took the Ethernet cable and we simply went from the back of our computer into this trainer. We're not connected to the network. We're just connected to our PLC. And every PLC for every student has the exact same IP address, 192.168.0.10. If we were connected to the network, that would be a gong show, because every time that you tried to download to your PLC, you'd be sending it to every other PLC in the room. So the beauty of having the same IP address for every individual PLC is that we can all follow the same steps. And if you screw this up and you somehow assign a different IP address to the PLC and you can't talk to it, then I literally just go and grab another box, I bring it over, it has the exact same IP address, we power it up, we put our Ethernet cable to it, and we're rocking within 30 seconds. And then I take 15 minutes to recalibrate the IP address for that box there. So the reason why I'm using the same IP address is so that every box is the same, we can all follow the same steps. And if you screw this up royally, I literally just go and grab another Siemens trainer, bring it over to you, and you just keep going on page 7. Okay, so all we're doing is just confirming that this is 192.168.0.10. Okay, next thing I want you to do is minimize this. So you can see right here, there is an arrow that's going to minimize that properties for the PLC. And then I want you to go over here to the analog card. Okay, so the analog card, again, if I scroll back up, the analog card is right here. It's tied into these inputs right here, the analog input number 1 and 2, and the analog output 1 and 2. So we're going to click on the analog card right here. Okay, so that is right here. So this is the PLC that we just looked at. Now we're going over to this analog card right here. We're clicking in the general area of it. So it's a right click there. And then we're going down to properties. And as we bring up the properties, it'll bring up the properties for the analog card now. Okay, it may have opened it up to general here. what I want you to do is go to analog inputs. So if these guys are not open yet, then go with a single click on the arrow to AI4, AQ2. Okay, so that means that analog inputs, there's 4 of them. Analog outputs, there's 2. And I want you to just do a single click on analog inputs. And then I want you to take a look at channel 0. Okay, so channel 0 is for the voltage. Okay, and that corresponds to this input right here, analog input number 1. So we're going to set that up as a voltage. We know that from the previous lab with the calibration, we were looking at a 4 to 20 milliamp signal. So we're not going to be making use of this, but it's just we have one analog input that's set for voltage, and you'll see on the next page that the one that we're using is set for current. Okay, that could be set by clicking on this and deciding whether it's voltage or current. I'm going to keep it at voltage right now, and you'll see that channel 0 and channel 1 are identical. Channel 1, I do not have the option to change that bad boy right there. It's set for voltage. It is set the same as channel 0. Okay, if I change this to current, then you'll see that channel 1 changed to current as well. Okay, so they're tied together, channel 0 and channel 1. So we're going to set this for voltage. It's set for a 0 to 10 volt signal, and now 0 and 1 are now both set for voltage now. Beautiful. Okay, we're going to move on to the one that we're actually going to make use of. So go down to channel 2 and make sure that this is selected as current. Again, it could be set for voltage if somebody screwed this up. So set it for current. Okay, and then down below, I want you to set this for 4 to 20. So there's an option for 0 to 20, but we know that our signal is a 4 to 20 milliamp signal. So set the analog input 2, channel 2, for current input, and set it for 4 to 20 milliamp signal. Okay, you'll notice that channel 2 and channel 3 are now identical now. So now we've set up the first 2 terminals on our trainer for voltage, and the second 2 terminals now for current, and specifically a 4 to 20 milliamp signal now. Okay, it says I'd also like you to note that the channel address for the analog input is IW100. Okay, well, let's see. Channel 2 is in fact IW100. And look, you can't change that whatsoever. That's set from the manufacturer. So if I want to look at that input, that analog input, I'm going to have to look at %IW100. That specific word of information is looking at the analog input coming in, right? So you can see right here that analog input number 2 is looking at %IW100. So within our PLC program, we have to keep track of that. Okay, excellent. So it says, excellent, now you have hopefully have an understanding of how to set the IP address for the PLC and how to assign the analog inputs and outputs as either a voltage or a current input. So now what we're going to do is we're going to compile, and we're going to hit hardware, rebuild all. So let me bring up this guy right here. And so what we're going to do is we're just going to click on the PLC, right? So click on the entire PLC. Okay, there is an option up here to download to the PLC, but we want to download the hardware changes that we've just made to there. So we're going to, I believe, right click on this guy, and then we're scrolling down to download to device, and you can see that it gives you a number of different options here. So we can download the hardware and the software only changes. We can download hardware configuration, or we can download the software. Well, it's asking us to download the hardware configuration. Okay, now you can see here that in the actual lab, it says there's another option. It says hardware rebuild all. So you'll see that at different points, different options will come in. So somebody may have already worked on this PLC, or guaranteed they worked on this PLC, because I have the intermediate guys and the advanced guys working on this particular trainer. So somebody else may have dropped in a separate program or a separate hardware configuration to that PLC. So you will see minor changes between what is written here in the lab and what is actually available here in our TA portal. Okay, so we're going to download to the device, and we're going to download the hardware configuration. Okay, let me get myself out of the way because some other options are going to come up here. Okay, so here you can see that I would like you to do Profinet. So here for the PGPC interface, we're going to do PNIE, that's Profinet. The next one is there should be an Ethernet connection. Okay, and again, it's not going to be exactly the same. Here I'm working on the same computer as we have in the labs, so it is identical there. And then down here it says connection to interface subset. Here it says the option of Profinet, and for some reason it doesn't give me that option. It says directed slot right here. Don't worry about any minor changes there. Make sure you have Profinet, you're using the Ethernet connection, and then below here you're going to start a search, and it's going to tone out, and it's going to see whether it's talking to the actual PLC. Okay, so it's searching. Seems like it's found an accessible HMI and PLC there. It's trying to talk to 192.168.0.10. You can see right here that in your PLC program on your computer, that's the IP address that it is trying to interface with. Okay, right here, let's see if it comes up. Yes, so sometimes, and I'm not entirely sure, those of you guys who are watching this on YouTube, maybe you can give us an answer on this. Every time that we send a program to our PLC, it says that there's a problem found and that it needs to provide a separate particular IP address. So you can see here in the notes here that it's probably going to ask us to do 192.168.0.241. Okay, so let's do that. Let's first actually see whether we're talking to that PLC. So we're going to go back to here, and I'm just going to click on this flash LED, and I click on this, and we'll see whether the LEDs on the PLC. I don't know if you can just make out just above here, below the Siemens logo, the LEDs on the PLC are actually flashing there. Okay, so I'm going to deselect. Oh, I'm in my OBS. Where am I? There's too many screens. I'm going to deselect the flash LED. Okay, I'm going to get myself back to just the screen capture here, and I'm going to load this into the PLC. Okay, so here you can see the exact same thing, right? An additional IP is required. You hit yes. Beautiful. So 192.168.0.241 was added to the interface. I don't entirely know why that is. So those of you who are more knowledgeable than me in the Siemens software, put an answer as to why that actually is, why we always need to put an additional IP in it, why it doesn't take that 192.168.0. So let's hit OK. Okay, again, different options will probably come up here. So the next thing we need to do is this may have been pink. So we're going to instead of no action, we're going to stop all. So we're going to stop any PLC program that was running before, and then we're going to hit load. Okay, and then we're going to do start module. Okay, so make sure that you do start module. If you don't do this, so I'm going to do no action just to show you how to turn the PLC on if you screw this up. But please read through the thing. It does say start module. So click on start module there and then hit the finish. I'm not going to do that because some people are looking at this and it looks like the no action is actually highlighted. So again, you are starting the module, which is starting the PLC. I'm not doing that, just to show you how to fix it if you screw up. Okay, let's hit finish. Okay, once we've done that, then it says, hopefully you see the following and no immunities are mounting in the classroom. So hopefully you're seeing 0 errors and 0 warnings. Beautiful. So that's what we're seeing right here, which is beauty. Okay. It says if you saw that loading complete, 0 errors, 0 warnings, then everything is going is set to go forward to the PLC program. Don't worry if there's one warning. It's most likely we have no security measures in place yet. Do we have any warnings? No, there's no warnings. So don't worry if there is one warning. It may be just that you haven't put any protection there for hackers to get to your PLC. Okay. At this point, I need you to save the program. Right. So we're going to go to project, and we're going to save this, and then go to the desktop and save this guy with whatever name. Right. So so you can put in base PLC program. Right, and then you put in your name or whatever works for you, right? Try not to use swear words or anything because it's going onto the desktop there, right? But put in like Team V, right? So something that you're going to remember later on, okay? If you put it to the desktop, then the beauty of that is that I'm not going to wipe out your PLC program, because oftentimes I will replace the basic, intermediate, and the advanced folders. So if you save it to one of those folders, like the intermediate folder, then it could be that I might wipe out all your work later on. Okay. The place where it's actually usually placed is in the documents folder under automation. So just to keep in mind, if you are watching this on YouTube, I've asked my students to go just to the desktop so they can reference this at any time. But the other place or the main place where Siemens usually puts the programs is within documents and automation. And once you open that up, then all your PLC programs that you're working on will be available here. Okay. All right. So we are good. We have saved this. You haven't overridden my base PLC program, so that I can have the next students in the next class open up my program and then go through all those steps, and then they can save their program to the desktop. Okay, next thing we're going to do is it says in the project tree window, left click on the arrow beside program blocks, scroll down and double click on main OB1. Okay, so that is right here under PLC. We're going to do a single click on program blocks. And then right here on main OB1, we're going to double click on this bad boy right here. Excellent. Okay, let me get rid of this. So I'm going to minimize or collapse this so I see the area. This is the main area where we're going to do all of our PLC programming. Okay, on the right-hand side of the screen, expand the instructions palette. So that is right here. So see my mouse right here on the top right-hand corner. I'm going to go up to this arrow right here and open up the instructions palette. I'm going to move this over right here. Okay. And you can see that, let me just show you a couple things. Under bit logic operations, that is where you're going to find the normally open and the normally closed contact that correspond to our favorites up above here. But again, I said that I'm going to throw you right under the bus. We're going to start to do some complicated programming. So we're going to, let's see, looks like conversion operations. So let's find that. So we have bit logic, there's timers, there's counters, there's comparators. We're looking for conversion operations right here. Okay, so we're going to do a single click there and open up that. I need a little bit more room, so can I bring this down a bit? There we go, okay. And there you're gonna see the NORMx and the SCALEx. Okay, so first thing I want you to do is grab a NORMx. So you're left clicking on the NORMx. Now I'm left clicking. It could be that in the lab you're right clicking, depends on the mouse configuration there. But in my case, I am left clicking, dragging this over until I see green and letting it go. That brings in my normalize. Okay, I'm going to go through what this actually does in 2 seconds. Above, we have SCALEx. So grab that bad boy and drag it over and drop it in, and then you'll have the SCALEx function. Okay, if you want to do something like a little bit cooler, or you want to or you're a little bit more proficient, you can actually come up here and it grabs like an empty box, which is a nondescript thing that you just drag down until it's green, let her go. And then when you type in here, you can type in SCALEx and it comes up with the instruction. And then when I hit anywhere on the outside there, then the SCALEx function comes in there. Okay, so let me go like this, and I'm going to make this a little bit larger so everybody can see. Okay, so at that point we have the NORMx and the SCALEx. Okay, there's a description here. If you want to find this description, then you click on this guy and then you hit F1 and it will come up with the information system. Taking a little bit of time to come in here, but this gives you a background on everything that's available within the TAA portal. So I've just done a screen grab of the NORMx, but essentially what's happening here is that this is going to normalize the signal coming in from our analog input. So we're going to have a signal that is really in actual fact 4 to 20 milliamps, this is going to take the 4 to 20 milliamps, well, not this instruction, but the analog to digital converter on the PLC analog card, takes the 4 to 20, changes it to 0 to 27,648. And this instruction here is then going to normalize that 0 to 27,648 to 0.0 to 1.0. So it's basically going to give you a percentage from 0 to 100% that corresponds to that 4 to 20 that has now been changed to a 0 to 27,648. If we look at the SCALEx function, that's then going to scale the normalized output, and you can scale it to whatever you want. We're scaling it to a 4 to 20 milliamp signal, and we're doing all of this work here in order to have the output of the SCALEx matching with the actual current that we're bringing into the PLC there. Okay, so the NORMx provides us with like a normalized output, a 0 to 100%. And we're going to make use of the SCALEx to actually scale that out to 4 to 20. Okay, the first thing I need you to do is go up to the top and click right here. And you can see that this comes up with all the different variations in formats of the inputs here. You can see that here we have all reds. Reds means the PLC is angry with you. It says, I don't know what you're talking about. Please just tell me what you're talking about. Okay, so what I need to do is go down here to and click integer. Okay, so what we're going to do is we're going to have a 0 to 27,648 signal coming in, and those are going to be integers in that they're not going to make use of any decimal places. Okay, but I want the output to have a value between 0 to 100%, right? The output of the normalized function is 0.0 to 1.0. So I need to make use of the decimal place. In order to do that, I need to make use of real values. Okay, so real values are values that are going to make use of decimal places. Okay, I'm just going to move this over so I have more room and you can see what I'm doing. Over here for the SCALEx, I need this to go from a real, because I'm going to take this value right here and bring it into here. So I have a real value on the output of the NORMx, so I need a real value going into the SCALEx here. Okay, the output, I want to keep as many decimal places as possible, so I'm going to keep this as a real value going out. Excellent. Okay. The PLC is still angry with me because I still have reds there. So let's see if we can get some blues coming in here. So the next step is we're going to put in the address first. Okay. So the next thing it says this will be the input for the NORMx. Earlier we made note that the analog input 2 of the analog input module has the address of %IW100. Okay, so enter the %IW100 for the value. Okay, that is the first thing we need to do. Okay, so don't start going like this, analog input, right? So once I do that, it just puts it in quotes, and the PLC is like, great, that's the name, but where do you want me to put that? What are we talking about? So PLCs need an address first. So put in %IW100. And then either hit enter or click over here, and you'll see that that looks good. It's coming in as like a green bluish, right? I'm going to call that blue from now on, but blue means good. Blue means that the PLC says, all right, beauty, I know where IW100 is. I know what you're talking about. I have no idea what you want to name this, but I know exactly where you want me to look. You want me to look at the analog input number 2 because I know that that is labeled as %IW100. Okay, so that is an input. So on these guys, they always use %. Then the I corresponds to input. W is word, and then it's using the word 100 there. Okay. As soon as we do that, we can now. It says you can rename IW100 by left-clicking on the tag and selecting rename tag. So let's do that. Analog input to 4 to 20 milliamp. Okay, now it's good. I don't know why it didn't work. So now that name corresponds to the IW100. Let me just show you here that under your PLC tags, So I went that a little bit too fast. I opened up my window here. I went down here past the main OB1 and I clicked on PLC tags, and then I'm going down to show all tags. So I'm going to double click here. And now you can see here that I have my IW100, and now it has the name analog input 2 4 to 20 milliamp raw value. And you can see below here, now I have my main OB1 and my PLC tags. So now I can go back and forth between those guys. Okay, beautiful. So now I've got IW100 coming in as the value there. Okay, these guys are still angry with me. So I need to put in a value. This is an integer value, so I'm not putting any decimal places. And I'm just going to put 0. And down here, I'm going to put 27,648. Okay, so for those of you who have done some PLC programming, the Allen Bradley actually makes use, so Allen Bradley PLCs make use of 32,767. This Siemens 1200 PLC goes from 0 to 27,648, corresponding to the analog input. The Siemens makes use of the extra digits between, or extra bit values between 27,648 and 32,767 to bring in different alarms and stuff like that. So different PLCs will have different numbers that correspond to their analog inputs. The Siemens PLC, the standard is 0 to 27,648. Excellent. Now we've got those values in. Let's save this because we've done some changes there. Okay, so we'll keep saving as we go through. The next thing we need to do is we're going to create a double word to hold the output of the NORMx. Okay, so I don't know if you can just make it out here. I have %MD50. So how did I come up with %MD50? Well, I was working on something where I had like some fancy stuff going on for like an all-encompassing program where I had a separate screen doing all kinds of other things. So by the time I worked up to this program, I was already at MD50. So if you're at home, you can choose whatever word you want. I'm just deciding to start at %MD50 just because I was working on some other things and I had already used all the other memory bits up to this point here. Okay, so this is just a random number that Pete came up with. Okay, so we're making use of a double word in order to use all of the like a large area, a large double word, in order to keep track of the real value output of the NORMx. Okay, so that guy is %MD50. I have created the address first. So remember that you create the address first and then you rename it. Okay, so for this guy, I'm going to label this as 4 to 20 milliamp NORMx output. Okay, so I'm putting as much information there as possible so that when I go and grab these tags later on, or I want to grab these guys with my HMI and have it corresponding to these, then I have labels that give me a lot of information as to what that actual tag does. Okay, so I'm going to hit change and now it has the name there. Beautiful. I want to also have that output of the NORMx go into the SCALEx. So what I'm going to do is I can put %MD and it already comes up with MD50. I can also just click on here, and then to the right hand side here you can just maybe make out that there's a drop down menu and it gives me all of the tags that I've created so far. So there's my IW100 and there's my MD50. So I'm going to click on this guy and then it comes up with the same tag right here. So the values here, right, where this is going to go from 0 to 27,648. We've seen in the description of the NORMx that it's going to change these values to 0.0 to 1.0, so 0 to 100%. That 0 to 100% is now being pumped into my SCALEx function here. Excellent. Okay, next thing I wanted to do is I want to scale this 0 to 27,648 to a 4 to 20 milliamp output. But not just 4, I need 4.0, right? So because I'm making use of real values, I'm making use of decimal places. Let's put decimal places in here for our min and our max values. Beautiful. So now we got a min and max value here. And the trick is that every time, so I'm on page 18 now, every time that I go to a next double word, I have to increase that double word address by 4. So I'm going to put %MD, I had MD50, I'm going to put MD54. Okay, if you don't do that, then you're going to, let me just bring myself up here. So if you don't do that, you're going to have bits of information that are overlapped together. So if I don't separate these guys in being one being MD50 and the next being MD54, then like say I said MD52, then all of a sudden I'm going to have a little bit of bits of information that are going to be overlapped, and then I'm going to be tearing my hair out as to like why things aren't actually working. So just keep in mind that every time you make another double word, you have to increase by 4. Otherwise, you'll have bits of information that are overlapping, and then these bits will then screw each other up, right? So we need to have a distinct separation between the NORMx output and now the SCALEx output there. Okay, so hopefully that's clear. Okay, so I'm now going to MD54. I'm going to right-click this on this guy and rename the tag, or I can go here to my PLC tags. There's my MD54, and I want to label this guy as what looks like 4 to 20 milliamp scaled input value. Excellent. Okay, and then when I go back to my main OB1, then that has now changed there as well. Beautiful. Okay, it says, please make sure to rename each of the tags as seen above. This makes it so much easier to distinguish what each address is for. If you have other names that make sense to you, go for it, but then you might get confused later on in the lab here because I'm using those distinct names going forward. Okay. Then it says, awesome, you've now created the basis of a really cool PLC program. This is pretty cool. It does it in one line of code. It takes the analog input and then scales it out to provide us with a 4 to 20 milliamp output there. Okay. The next thing we need to do is compile to make sure that there's no errors. So in order to do that, up here, I don't know if you guys can just make out that I have this guy right here is the compile, and this one is the download to the device. Okay, so let's hit compile first. And when I hit compile, it's looking at everything I've done and seeing whether there's any errors whatsoever. Okay, so right now I have 0 errors and 0 warnings. Let me show you if I screwed something up. So maybe by mistake, I put in another rung, but I didn't put anything on that rung. If I compile that, then it's angry at me, right? There's red over on the side here. So it says that there's a warning. And when I click on this, then it should bring me to or highlight the exact thing that is causing issues. Okay, so I'm going to get rid of this and get rid of that. And I'm now going to compile. And the compile is saying, is everything cool with this program? Have I done everything correct? Have I selected the format of everything? Have I got the right addresses for things that correspond to the NORMx and the SCALEx? Is everything cool for me to download to the PLC? Okay, everything looks good because I have 0 errors and 0 warnings now. Beautiful. Now we're going to download to the PLC. So again, you can come over here and you can right click here on the PLC and you can download. We haven't made any hardware changes, so we can download our software. We can either do the changes or we can download all. And the other option is we can come up here and right beside the compile, we can hit download to device. Okay, I tend to like going over here, go to download to device, and I'm not sure what I've done. I don't think I've downloaded any software yet, so I'm going to download software all to the PLC. Okay, again, you may have minor variations in the difference in what is shown here on the screen, depending on whether you have downloaded something before or something else has downloaded something to the PLC. But it looks like these guys are identical, so I'm going to load that in. Okay, over here it says no action, so now I'm going to hit start module here. Okay, so please make sure that you hit start module. I'm not going to do that, and I'll show you how to turn the PLC on in 2 seconds. Okay, so we're going to hit finish. Okay, but you are going to hit, no, you know what? I'm going to do start module. I'm going to follow my own instructions, and then I'll show you, if you didn't do that, how to turn the PLC on. So let's hit finish. Okay, and down below we can see here 0 errors and 0 warnings. Beautiful. Okay, so that means that the PLC program has been downloaded properly. Okay, and I'm going to make this just a little smaller here. Okay, and then it says to go up here to the top here. So hopefully you have this available. If you don't, then call me over and I'll show you how to bring up this monitoring on and off. You may have to make the TIA portal take up the whole screen so you can actually have this come in. We're going to hit monitoring on and off, and then hopefully on the side here, these guys go green, gorgeous. And then within our PLC program, this guy goes green here as well. Okay, so green means that everything is live and we're seeing values come in. Nice. Okay, so right now I don't have anything coming in. I have 32,767 coming in. I have 1.18, 1.18, and I got 22.96. The reason for that is that I don't have anything hooked up to my actual PLC yet. So let me just take 2 seconds. Let me grab my simulator and I'll show you how to hook this guy up to the actual PLC. So let me grab the simulator here. 2 seconds. Beautiful. Okay, so what we're going to do is we need to, so this is our simulator right here. And what we're going to do is we're going to connect up 24 volts to this guy. So there's 24 volts available. Sorry, let me go like this so you can see 24 volts available here and here. Okay, so I'm going to hit or connect up the 24 volts here. I'm going to put the negative to this guy, and that will then juice up my digital display here. Okay, and then I need the inputs going to my analog input 2. So you can see these 2 wires coming off the top here. Right? I don't know if you can just make out that that is the 0 to 20 milliamp output. So we set up analog input 2 for the 4 to 20 milliamp current going into there. So I'm connecting up 24 volts to the simulator. Then I'm connecting up the output of the simulator to the actual analog input number 2 here. Okay, you can see here that I'm at 11.80. I'm going to ramp this down and I'm going to bring it to something just above 4 milliamps. Okay, so I got 4.04 milliamps going in there. Okay, so let me just put that down and let me make the screen larger again, or get rid of, or just let me see if I can move this TIA portal over so you can actually see the 2 coming together here. Yeah. Okay, so let's take a look at this. We got 4.04 milliamps going into that input there. And what do we have on the screen? Looks like 4.00. So there's going to be a minor difference in the resolution between this unit and the TIA portal there. If it's not coming in like that, then it may be that the display format for the network is in hexadecimal. So you may see something crazy like this where it's coming in hex. So right click on your NORMx, go to display format, go down to the network, and then display the values as a decimal there. Oh, maybe not. Maybe we need floating point. Let's go to network and let's do floating point. Yes, floating point is the value coming in there. Beautiful. So now we can see the input into IW 100, which is very low right now. So what it's doing is it's taking the 4 to 20 milliamp signal going into the NORMx, breaking it up into 27,648 different small pieces. This is normalizing it. So here we have basically 0% here. And you can see that the same value is coming, the same value as our current simulator here is being seen on the TIA portal here. Okay, keep in mind that this simulator here has the ability to go below 4 milliamps, and you can see there that I'm at 2.95, and now we got some messed up values. I got like a negative value here, right? So keep in mind that ours is looking at a 0 to 27,648 that corresponds to a 4 to 20 milliamp signal. So we have to be above. So watch this. I'm just going to ramp this up, and we're going to go above 4 milliamps. And as soon as I go above 4 milliamps, beautiful. Now the values are coming in properly. Okay. So let's go between, let's do each 25% increase here, and we'll see the values coming in. So I'm going to go from 4 to 8 milliamps. Okay. A little bit of a pause there as it comes in. So we got beautiful. So we got 8.07 milliamps coming in there. And on our TA portal, we have basically 8.04. So again, small resolution difference between those. But that's awesome now. Now we've got the actual current being seen on our PLC program. Okay, then I'm going to go to 12 milliamps. Okay, so that would correspond to 50% in the tank here. So the beauty of this is that we can just use this simulator and we can simulate the 4 to 20 milliamp signal. We don't have to go through all the same steps of hooking up our DP cell and having that going into our PLC. We're just making sure that the PLC program is working. So that's why we're using this simulator here. I got 12.08 on the current simulator. And on TA portal, I have 12.04. Awesome. And you can see in the center there between NORMx and SCALEx that that's corresponding to 50% input. Beautiful. Let's go to 75%. 75% is 16 milliamps. Beautiful. Okay, 16.09. You can see there that the output of the NORMx %MD50 is basically 0.75, corresponding to 75% of the range. And on the output of the SCALEx %MD54 is very similar to the current that we're seeing here on the simulator. 16.09 on the simulator, 16.04 on our PLC program. Awesome. Okay, let's go up to 20 milliamps. Okay, so I got to go below the 20 milliamps there. Okay, come on, buddy. Okay, so basically 19.97, and I got 19.91 there. Okay, so a little bit of resolution issues there at the top end of the range. There I got 20 milliamps, and I basically have 20 milliamps going out. Looks like I have to go a little bit higher on the simulator in order to get my full 20 milliamps out there. Okay, so you can see there that on the input to the NORMx, that's the 27,648 that's coming in there. Hard to get it exactly to that value there, but we can see the 20 milliamps coming in is 27,600 and then right now 15, right? So very close to the 27,648 that's going in. We're at 0.999 coming out of the NORMx, and then the output of our SCALEx is exactly the same as the current we're seeing on this simulator there. Awesome. That's your first PLC program so far, and you have it mimicking exactly what we have on the current simulator. Beautiful. Okay, so that's probably taken us at least a half an hour to get through, but you have successfully created this portion of the PLC program, and it's matching exactly with our current simulator. And so later on, when we hook up our level DP cell that gives out the same current output, then we should see that right here at 16 milliamps, we should see 75% output there. Beautiful. Okay, so let's keep moving on with the rest of the PLC program. This might be as far as you get in the first hour, right? So you may have calibrated the DP cell, and this is the end of the first lesson. So this would be a pretty good place to save. So I can go offline here. Let me just go back to the screen capture here. So I can go offline by hitting the Corey Hart sunglasses here and hit yes. Okay, I've done a lot of changes and I've got a program that's actually working. So I'm going to hit save project. I've saved it to the desktop, and this might be a good place to stop the video and come back next class and start to work on the rest of the PLC program.